So in section 3.4, we are talking about the real zeros of polynomial, okay, and also will be try to solve some of the equation. And now real zero means these are the inputs, right? These are the x values that give us output equals to 0. So every input which give us output equals to 0 is the real zero, okay. Real zero are also the x-intercept. So once you find the real zero, those real zero are also the x-intercept, okay. And the real zeros are also the solution for the equation. So here, so we have our polynomial p of x, okay. So p of x is our polynomial, and if c is a real zero for this polynomial, then if you find the output for that polynomial, you always end up getting 0, okay. C0 is the x-intercept, okay, and x minus c, okay, x minus that real zero is a factor, is one factor for the polynomial p of x, okay. Now today, so let's find the number of real zero for the polynomial, okay. Now we have a polynomial p of x and degree is n. So if we have a polynomial function p of x with a degree n, then we can always find n number of real zero, okay. At least we can find n number of 0. So the number of 0 would be equals to the degree of a function or less than a degree of a function, okay. Okay, like here, so the very first example, this is our polynomial function. What is its degree? Degree is the 3, right? So 3 is the degree for this function. So the number of 0 that this function will have will be equals to 3 or less than 3. And we did calculate the zeros for this function, and we had 3 zeros. See, we had 4, -4, and 4/3. Okay, so once you know the degree of a function, you can find how many zeros that function can have. Okay, that number of 0 is equals to number of degree, or it can be less than the degree of a function, okay. Next here we have our rational zero theorem, okay. So we have a function here, polynomial function. So let's consider we have any polynomial function, okay. Then p over q is a rational zero, okay. P over q is a rational zero, and here p is the factor of a naught. A naught is the coefficient of leading term, and q is the factor of the constant, okay. So here the rational zero, so let me write one more time. So our rational zero is p over q. Rational zero is p over q, okay. P is the factor of coefficient of leading term, coefficient of leading term. So we write down every factor of a coefficient of a leading term of the function. P is the coefficient of leading term, and q is the factor of constant. In a function, we can find the leading term, okay. We write down every factor of a coefficient of leading term, okay, and we divide that by the factor of a constant of the function. So, and this p over q is the rational zero. Now this rational zero help us to find the real zero for the function, okay. Our target is finding a real zero, okay. To find the real zero, we have option from -infinity to +infinity. We have like infinitely many options, okay. But once we know the rational zero, we can pick our real zero. We can look our real zero from the rational zero. We can always find a real zero in the rational zero, okay. So it helps us to find the real zero. Okay, it give us the limited option, okay, finite option, and from that option we can find the real zero for the function. Okay, and the rational zero is always the factor of coefficient of leading term divided by factor of a constant. Now let's take an example, it will be more clear. Now we have this polynomial function p of x equals to 3x cubed minus 6x squared minus x plus 2. Now let's find the rational zero, which is p over q. Now what is p? P is the factor of coefficient of leading term. Now in this function, which one is the leading term? 3x cube is the leading term, and what is its coefficient? 3. So we write down every factor of 3. So every factor of 3 means we write down every number that divides 3. Okay, what are those numbers? Okay, 3 and 1. Do we have any other number? What about negative 1? Can we divide 3 by negative 1? We can, right? 3 divided by negative 1 is negative 3. We can use negative 3. 3 divided by negative 3 is negative 1. So positive 1, negative 1, positive 3, negative 3. All these are the possible values for p. Okay, so we write down every factor of coefficient of leading term. Okay, that these are our p options for p. And q is a factor of a constant. Now in this function, what is our constant? 2. So constant is the term without variable. And what are the factor of 2? So we write down every factor of 2. So positive 1, right? Negative 1, positive 2, negative 2. So make sure you include positive and negative number, because we can divide our 2 by negative 1, right? 2 divided by negative 1 is negative 2. We can divide 2 by negative 2, we get negative 1. So factor means we are writing every number that divide constant, every number that divide the coefficient of leading term. Now, so we have 4 options for p, we have 4 options for q. Okay, now from these options we find what is our p over q. Now we need to find, so let's take 1 for p and 1 for q. So if we have 1 for p and 1 for q, what is our p over q equals to? 1, right? Now let's take 1 for p and negative 1 for q. So if we take 1 for p and negative 1 for q, p over q is 1 divided by negative 1 is negative 1. Similarly, let's take 1 and 1 for p and 2 for q. So p over q would be 1 over 2. Okay, so let's take 1 for p and negative 2 for q. So p over q would be 1 over 2, or like negative, so 1 over negative 1 over 2. Now let's take negative 1 from our negative 1 for p. Okay, so let's take negative 1 for p. So we are taking negative 1 for p. Okay, so we are taking negative 1 for p and positive 1 for q's. What do we get for p over q? So negative 1 divided by 1 is, we get negative 1. We already have negative 1, so no need to rewrite. Okay, so let's take negative 1 and negative 1. So negative 1 divided by negative 1 is positive 1. We already have negative 1 for p, 2 for q. So negative 1 divided by 2 is negative 1/2. We already have negative 1, and let's take negative 2. Negative 1 divided by negative 2 is positive 1/2. We already have here. Okay, now let's go with 3. So let's choose 3 for p and 1 for q. So 3 divided by 1 is 3. Okay, let's choose 3 for p and negative 1 for q. So 3 divided by negative 1, that is negative 3. Okay, let's choose negative 3, sorry, we are choosing positive 3 and positive 2. So we get positive 3 over 2. Let's choose 3 for p and negative 2 for q. So we get negative 3 over 2. Now we have negative 3 to choose here. So if we choose negative 3 for p and 1 for q, we get negative 3, right? We already have here. Let's choose negative 3 and negative 1. We get positive 3. We already have here. Negative 3 and over positive 2. We already have negative 3 over 2. negative 3 divided by negative 2, we have positive 3 over 2. So these are the rational zeros. Okay, so you have the 4 options for P, you have the 4 options for Q. Okay, so you have to make sure you take every terms here, every number here. Okay, now out of these rational zeros, we can always find the real zero. Now you have this option. Okay, now if we didn't define the rational zero, our option is from negative infinity to positive infinity. Any number can be a real zero for this function. But once we know the rational zero, we have these options. So we have 1, 2, 3, 4, 5, 6, 7, 8 options. And out of these 8 options, we can always find the real zero here. Okay, and how do we find which number is a real zero for this function? So how do we find that? Okay, if you use the synthetic division, what makes you decide that given this number is a real zero? So you have to try synthetic division for each number, right? So if you get the remainder equals to 0, then that number is a real zero. That is one way. So what is the other way to check whether these numbers are a real zero or not? So we use the factor theorem. So these are the number. So if you substitute this number for every x, okay, so these are your x. If you substitute this number for every x in the function, and if you get output equals to 0, then the input is the real zero. So that would be the easiest way. So let's choose one number from this list and substitute for every x. If we get 0, then that number, that input is a real zero. Okay, let's try with a positive 1. If we substitute 1 for every x, okay, we get 3 minus 6. That is minus 3, right? Minus 1, that is minus 4 plus 2, we get minus 2. So 1 is not a real zero. Okay, so 1 is not a real zero. Let's try for negative 1. So if you substitute negative 1 for every x, so we have 3 times negative 1 cube, that is negative 3, right? So we have negative 3 minus 6 times negative 1 square, we get negative 6. So that is negative 9 plus 1, negative 8 plus 2, negative 6. So negative 1 is not a real zero here. Okay, so let's try other number here. Okay, so let's try, before fraction, let me use 3 and negative 3. Okay, that's easy here. So let's check whether 3 is a real zero or not. Okay, let's substitute 3 for every x. So we have 3 times 3 cube. 3 cube is 27. 27 times 3 is 27 times 3, that is 7 times 3, 21, 81. Okay, 81. So we have 81 here. Okay, and minus 6 times 3 square, which is 9. So 6 times 9, that is 54, right? 54 minus 81, that is 660. We need a calculator here, right? Okay, what do we do? We just substitute this number for each x, and we look for the number that give us 0. Okay, let's find one, at least one. Okay, so looks like 3 is okay. So let's substitute here. So we have a 3 times 27 minus 6 times 9 minus 3 plus 2. So this is 81 minus 54 minus 3 plus 2. We don't get 0 here, right? So we don't get, because 81, so we don't get 0 for 3. So let's try negative 3. 3 times negative 3 cube is negative 27. So we get negative 81. So we get negative 81 minus 6 times, that is 9. We get 6 times 9 plus 3 plus 2. Okay, this does not give us 0 here. So we have the fractions. We have to use the fraction here. Okay, let's go with 1/2. So we have, let's use 1/2 for every x. So we have 3 times 1/2 cube, that is 1/8, minus 6 times 1/2 square, that is 1/4, minus 1/2 plus 2. Okay, so here we have 3/8 minus 6/4 minus 1/2 plus 2. 8 is the common denominator, right? So let's make denominator equals to 8. You multiply 2, multiply 2, multiply 4, multiply 4, multiply 8, multiply 8. Okay, we have 3 over 8 minus 6 times to 12 over 8 minus 4 over 8 plus 16 over 8. Do we get 0 here? Okay, negative 12, negative 4, that is negative 16. 16 plus 3, that is 19. So we don't get 0. Okay, so it's not helping us here. So let's take negative 1/2. Negative 1/2. Okay, so if it's negative half, we get negative here, we get positive here, we get positive here. So we have negative 3 over 8, negative 6 over 4 plus 1/2 plus 2. 8 is the common denominator, so let's multiply this by 2, by 4, by 8. So negative 3 over 8, negative 12 over 8 plus 4 over 8 plus 16 over 8. So 16 plus 4, that is 20, 15. Okay, this is not 0. Okay, so we have the option 3 over 2 and negative 3 over 2. Did anyone find? Let me know. Okay, if you find, we need to find at least one real 0 here. Okay. Okay, let me go with let me double check 1 and negative 1. Okay, like in general, like 1 and there, so we always look for the 1 and negative 1. Let me double check. So we have 3 minus 6, that is minus 3, minus 1, that is minus 4 plus 2. Okay, 1 is not the real 0. Let's try for negative 1. We get negative 3 there, and we get negative 6, negative 9. Yeah, okay, these two are not. Okay, so we have the last two options here. So let's try 3 over 2 for every x. So we have 3 times cube of 3 over 2 is, cube of 3 is 27, cube of 2 is 8, minus 6 times the square of 3 over 2, that is 9 over 4, minus 3 over 2 plus 2. Okay, so you substitute this number for every x. Okay, that's what I'm doing here. And we want a number, we want our output to be equals to 0. That's what we want here. Okay, so we have 27 times 3, that is, okay, 81 divided by 8 minus 54 divided by 4 minus 3 over 2 plus 2. So 8 is the common denominator. So let's multiply by 2, by 2, by 4, and by 8. Okay, so we have 81 over 8 minus 54 times 2, that is 108 divided by 8 minus 12 over 8 plus 16 over 8. Okay, 81, so this is positive. 81 plus 16, that is 97 over 8, right? Minus 108 minus 2. We don't get 0 here. Okay, should be the negative 3 over 2. That should be our last option here. Okay, the last option is negative 3 over 2. Okay, 3x cubed minus, let me double check my equation. 3x cubed minus 6x squared minus x plus 2. Okay, now looks like, okay, I find the mistake here. Now our rational theorem, the way that I define the rational theorem, that is, okay, now we need to flip our P and Q here. Okay, now here, let me go back. Okay, I'm sorry for that. Now here, so our P, so P is the factor of A naught, and A naught is a constant. Okay, and Q is the factor of coefficient of leading term. Okay, we had a wrong here, so we need to switch this here. So the way we define P and Q is incorrect. Okay, so let me correct that. Okay, so let me correct this part here. So P is the factor of a constant, okay? P is a factor of constant. And Q is the factor of coefficient of leading term, okay? So Q is the factor of coefficient of leading term. Now the way we define the rational term is incorrect. Now every will be incorrect. We just need to switch our P and Q. Okay, so P is the factor of constant and Q is the factor of coefficient of leading term. If this is the case, now we just flip here. So our P, so our Q, and so P is the factor of constant, which is 2. So the factor of constant 2 is 1, negative 1, positive 2, negative 2. Okay, our Q is the factor of coefficient of leading term 3. Okay, and this factor are positive 1, negative 1, positive 3, negative 3. Okay, now let's find our P over Q one more time. So P is the factor of constant and Q is the factor of coefficient of the leading term. Okay, so we have, let's find P over Q. Okay, so if you choose 1 and 1, we get 1. 1 divided by 1, we get 1. So if you choose 1 and negative 1, we get negative 1. Okay, if you choose 1 and positive 3, we get 1 over 3. If you choose 1 for P and negative 3 for Q, we get negative 1 over 3. Okay, and if you choose negative 1, you're gonna get the same number here. Okay, we're gonna get the same number. So let me go to 2 here. So if we choose 2 for P and 1 for Q, we get 2. If we choose 2 for P and negative 1 for Q, we get negative 2. If we choose 2 for P and 3 for Q, we get 2 over 3. And if we choose 2 for P and negative 3 for Q, we get negative 2 over 3. And for negative 2, we're gonna get the same number here. So these are our new rational zeros. Okay, now so here in these rational zeros, we already checked for 1 and negative 1. So 1 is not a real zero, negative 1 is not a real zero. So let me go with 2 here. Okay, so let's substitute 2 for every x. So we have 3 times 2 cube. 2 cube is 8. 8 times 3 is 24, right? Minus 6 times 2 is square. 2 square is 4. 4 times 6 is 24. So we have 24 minus 24, that is 0. And negative 2 plus 2, that is 0. So 2 is the real 0 here. Okay, so one real 0 is 2. And how we know that? You substitute 2 for every x. So we have 3 times 2 cube minus 6 times 2 square minus 2 plus 2, and this is equals to 0. So if you get output 0, okay, when you substitute this rational 0, if you get output 0, then this 2 is the real 0. This 2 is the x-intercept. Okay, if 2 is the real 0, what is one factor for this polynomial function p of x? What is the fact? What will be the factor? X, every time x minus that real 0. Okay, x minus 2 is one factor. So x minus 2 is a factor. Okay, now we are asked to find every real 0. Now how do we know how many real zeros this function gonna have? So we check the degree. The degree is 3. So at least there will be a 3 real 0. So we know one real 0. Okay, we already know one real 0. Now let's find 2 more real 0. Okay, and in order to find, you can use the same method here. So you can try substituting 1 over 3 for every x, negative 1 over 3 for every x, and the remaining number. Or we can use the synthetic division, factorize this polynomial function. And once we have the function in a factor form, it is easy to find the real 0. Okay, so let's go ahead and use the synthetic division and factorize this function. So we use this one factor as our divisor. Okay, we compare this factor with our x minus c, and if we compare, our c is equals to 2, right? So we are dividing the coefficient of every term of the function. So coefficient of cube terms is 3, coefficient of square term is -6, coefficient of x is -1, and we have a constant, and this coefficient of every term is divided by our c, which is 2. Okay, so we drop our first coefficient 3, so multiply 3 and this c, 3 times 2 is 6. We do not change signs. -6 +6 0, 0 times 2 is 0, -1 and 0, that is -1, -1 times 2 is -2, and this is 0. So whatever we have here, it is always our remainder r of x. Okay, now we can write our p of x equals to divisor. Our divisor is x minus 2. We use x minus 2 as our divisor, so our divisor x minus 2 times the quotient. Now how do we write the quotient? Quotient, in order to write the quotient, we need to know the degree of quotient. What will be the degree of quotient here? Yes, so the degree of function is 3. So if the degree of function is 3, the degree of quotient will be always less by 1. So 3 minus 2, that is, so 3 minus 1, that is 2. 2 is the degree. And to have a degree 2, we have the x square as a first term. This is our second term, and this is the constant. So 3x square, 0 times x, that is 0, and we have -1. So this is the factor for the polynomial function. Now let's factorize. Is there any way we could factorize this, the second factor, 3x square minus 1? Okay, now we need to know the real 0, right? So finding real 0 means finding the x-intercept. It's the same thing. Okay, and how do we find the x-intercept? We said this p of x equals to 0, right? So we have 0 equals to x minus 2, or let me write other way. So let me write right side first. So x minus 2 times 3x square minus 1 equals to 0. Okay, we have a two number, x minus 2, and we have this number, and their product is 0. Okay, if the product of two number is 0, what can we say about those two number? One of them has to be equals to 0, right? It means we set each factor equals to 0. So we have x minus 2 equals to 0, and we set second factor 3x square minus 1 equals to 0. Now let's solve this equation. So we add 2 on both sides. So x equals to 2. We already know this is the real 0, right? So this is our main target here. So let's add 1 on both sides. So we have 3x square equals to +1. Divide both sides by 3. So we have x square is equals to 1/3. And how do we get rid of square? We have positive or negative square root of 1/3. Okay, so our real zeros are 2, positive square root of 1/3, and negative square root of 1/3. Okay, so this is the real 0. Now if we compare our real 0 and the rational 0, so it's not true that all real zeros are the rational zeros. Okay, but we can always find at least one real 0. Okay, sometime every real 0 can be a rational 0. Okay, so finding the rational 0, it helps us to find the zeros of a function easily here. Okay, so this is how we can find the real 0 for the function. Find the rational 0. Okay, rational 0 is factor of constant divided by factor of leading term. Okay, and once you have the rational 0, you try those numbers. Okay, it's gonna be hit and trot. So you choose any number, substitute for every x. If you get output equals to 0, then that number is your real 0. And once you have a real 0, use the synthetic division. Okay, you are dividing coefficient of each term by that real 0. Okay, and write down your function in a factor form. You set each factor equals to 0, you set each factor equals to 0, and you solve those equations. Okay, and the solution of the equation gives you the real 0 for the function. Okay, now here this is not okay. Now so here this is interesting here. So we have a Descartes' rule of sign. Okay, so we have a polynomial function p of x. Okay, and k is the number of variation of sign of p of x. Okay, and we have a m, which is the number of variation of sign in p of minus x. Okay, the positive zero. Now when we find the zeros of a function, so it helps us to know how many positive zero we can find and how many negative zero we can find for a function with the help of this Descartes rule. Okay, so you have a function and you want to know how many positive zeros you can find, and if you want to know how many negative zero you can find, then we use this rule. Okay, now what it tells here is that, so we look for the number of variation of sign in p of x for positive zeros. Okay, and we look the number of variation of sign in p of minus x for negative zero. Okay, now we have here p of x. Now how many variation of sign do we have in p of x? So this is our p of x. Okay, so we have a negative sign for this first term, right? Then we have the positive sign here. Okay, then we have a negative sign here and we have a positive sign here. Okay, so we have 1, 2, 3 variation here. Okay, so you must have a sign, alternate sign, okay, to count as a 1. So you have a negative, okay, for first term, positive for the second, so it is 1 variation. Okay, right, for the second term, so you have positive here, so you have positive here, you have positive here, and you have negative. This is 2, right? Next you have negative here and you have positive here. So we have all together 3 variation. Okay, if this is the, so we have the 3 variation sign, means we gonna find at least 3 positive zero. Okay, so this conclude that there is 3 positive zeros. Similarly, we need to know, if we want to know how many negative zero we're gonna find. Okay, 3, okay, or less than. Okay, it's not always 3, or less than 3 positive zero. Now in order to know the negative, we find p of minus x. And how do we find p of minus x? We substitute negative x for every x in our p function. So we have negative 3 for every x. We substitute negative x to the power 4 plus 4 times negative x for every x square minus 3 times minus x plus 2. So we have negative 3. What is the fourth power of negative x? So fourth power of negative is positive. X to the power 4 is x to the power 4. Okay, plus square of negative x is positive x square. So 4 times positive x square, 4x square. Negative 3 times negative x, positive 3x, positive 2. Now we look for the variation of sign here. So here we have a negative sign and we have positive here. So this is 1 variation. Now, so we have a positive here, we have a positive here. It doesn't count here. You must have an alternate sign to count as a 1. Okay, and similarly, so you have a positive here, you have a positive here, it doesn't count here. So we have a 1 variation. It means we're gonna have 1 negative zero for the in this function. Okay, so there is 1 negative real zero. So 1 negative real zero. So this function, the degree is 4, so the function gonna have at least 4 zeros, right? And out of those 4 zero, 3 gonna be positive and 1 gonna be a negative. Okay, so it only tells us, like, if you are interested, then yeah, you can use this Descartes rule to find how many positive zero we can find and how many negative zeros we can find. Okay, and for exam, I think we don't, I checked your homework and we don't have any homework related to this rule. Okay, but we just did one example here. Now let me go to let me do some examples from your homework. Okay, so let me do number 29. Okay, so this is your homework number 29. and it tells us to find all the real zeros for the polynomial. Okay, so our polynomial is f of x equals to negative 4x to the power 4, negative 11x cube, negative x squared, negative 11x plus 3. So this is the function here, and we are asked to find all real zero for this polynomial function. So finding real zero means we need to find the x-intercept. Okay, in order to find x-intercept, what do? We set our f of x equals to 0 and solve the equation. But this equation has the degree 4, so it's not easy to solve here. We know how to solve quadratic equation. Okay, that's what we know. We haven't learned how to solve fourth degree equation and the third degree equation. Okay, now here we will use our rational zero. Okay, so let's find the rational zero at first, and out of that rational zero we can find one or two real zero. Okay, so let's find rational zero. So the easiest way would be finding the rational zero. Rational zero is p over cube, and p is the every factor of a constant. Okay, so this is our constant 3, and what are the factor of 3? Positive 1, negative 1, positive 3, negative 3. These are the factor of constant, and our q is the coefficient of leading term. So this is our leading term, its coefficient is negative 4. And what are the factor of negative 4? Positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. So these are our p and q. Now let's write down, let's choose our p and q and find p over q. So if you choose 1 for p and all these number 1 by 1, what do we get? 1 divided by 1 we get 1, 1 divided by negative 1 we get negative 1, 1 divided by 2 we get 1 over 2, 1 divided by negative 2 we get negative 1 over 2, 1 divided by 4 we get 1 over 4, 1 divided by negative 4 we get negative 1 over 4. Okay, and we get the same result if you choose negative 1. So you are not required to do for negative 1. We get the same number here if you choose negative 1 and all these numbers 1 by 1. So let me go with positive 3 here now. So let's choose 3, positive 3. Okay, and all these q number 1 by 1. So 3 divided by 1, 3, 3 divided by negative 1, negative 3, 3 divided by 2, 3 over 2, 3 divided by negative 2, negative 3 over 2, 3 divided by 4, 3 over 4, 3 divided by negative 4, negative 3 over 4. Okay, and if you choose negative 3, you end up getting the same result here. So no need to do for the negative number. So these are our possible real zeros. Now out of this, now we have so many options here. So we're gonna choose one number and substitute for every x in the function, and we look for output 0. And let's try for the 1. Okay, so always try with a small number. So if we use 1 as our x, okay, so we have negative 4, negative 11, that is negative 15, negative 1, negative 16. Okay, 1 does not give. Okay, so 1 is not a real zero. That's what we want, but this is not a real zero, sadly. Okay, let's go with negative 1. So let's substitute negative 1 for every x. So we have negative 4, that's positive 11. So negative 4, that's positive 7, minus 1, 6, minus 11. That's minus 5. That's positive. It's not, okay, it's not helping us. Negative 1 is not the real zero. Now let's go with positive 3. Then only we'll choose the fraction here. So let's choose positive 3. So if we choose x equals to positive 3, okay, I feel like maybe 1/2. I think let's try 1/2 before positive 3. Okay, let's see what happens. But you can just choose any number. Okay, you have the calculator, so you substitute this number 1 by 1, and you find the number that gives output equals to 0. That's the first thing here. Okay, if I choose okay, so this is negative, let me choose negative 1/2. So we have negative 4, times fourth power of negative 1/2, that is 1 over fourth power of 2 is 16, right? 16 negative, we get positive here, 11 times cube of negative 1/2, that is negative 1 over 8, and that makes positive here. Okay, and you can try for different number. Okay, so you don't need to just try for negative 1/2. So if you try different number, it would be easy for us to find which one is the real 0. Okay, so so this should be 1 over 4 negative, so we choose negative 1/2, so we're gonna have positive 11 over 2 plus 3. Okay, 16 is the common denominator, so we multiply by 2, we make it 16, multiply by 4, we get 16, multiply by 8, 88, we get 16, we multiply by 16 and divide by 16. Now does this give us 0? Negative 4, so we have positive 22, positive 18, it does not give 0. Yeah, this was a wrong choice. Okay, so let's go with 3. Okay, did anyone get the real 0? Let me know. Okay, and on your homework you do have a 4th degree, but on your exam you will have the function with a degree 3. Okay, so you won't have a function with a greater than degree 3. Okay, it's a time consuming, it takes a lot of time. Okay, but you will have a degree 3, and if you just try 1 negative 1, that will 1 negative 1 or like 2 negative 2, it will give you a real 0. Okay, so I'll just try to have a simple function on your exam, but on your homework, so this is your homework and this is not easy here, so it's gonna take a time here. So let's go with 3 here. So if I'm choosing 3, you choose different number. Okay, let's choose 3. So if I choose 3 for every x, so we have negative 4 times 3 to the power 4. So 3 cube is 27, 27 times 3, that is 81, right? So we have 81 minus 11 times 3 cube is 27, minus 3 square is 9, minus 11 times 3 is 33, plus 3. All these are negative, so we won't get 0. So 3 is not the negative 3. Did that give you a 0? Let's try negative 3. So negative 4 times negative 3 to the power 4 is positive 81, minus 11 times negative 3 cube is negative 27, negative 3 square is positive 9, so it's positive 33, positive 3. So we get positive here. Okay, this looks okay. Let's try this one, so we might get. So negative 4 times 81 is negative 324. Okay, now this is positive. Can anyone help me here? 11 times 27, 300. Did I hear 300? 297. Okay, thank you. So we have 297 minus 9 plus 3 plus 3. Do we get 0 here by any chance? So this is, we might get, let's see. So these two are negative, so we get negative 333. Oh yeah, we get this. So this is 300. Yes, so our negative 3, right? So negative 3 is 10. Finally we got. Okay, now so negative 3 is a real 0, so we use that negative 3 and use the synthetic division and factorize this function. Okay, so let's use. Does anyone have question how we choose negative 3? So you have, so it's gonna take time. Okay, you choose this number and substitute for every x, and if you get output 0, then you're gonna choose that number. So we divide this function using synthetic division. So in order to divide, so we have negative 4, the coefficient, then we have negative 11 here, we have negative 1, negative 11, positive 3. There is no missing term. If you have a missing term, you're gonna use a 0. Okay, so we have x to the power 4 cube 2x 0. Okay, so no missing term. So let's drop this one, negative 4. So negative 4 times negative 3, that is positive 12. So this is positive 1. 1 times negative 3, negative 3. So this is negative 4. Negative 4 times negative 3, that is positive 12. So we have 1. 1 times negative 3, negative 3, this is 0. So this is our r of x. Okay, now so we have our f of x. We can write our f of x as a divisor times the quotient. Now what is divisor here? So we know this is a real 0. If this is a real 0, what is the one factor for this function? X minus this number, which is x minus minus 3. We get x plus 3. So x plus 3 is the divisor times the quotient. So we have this number, the coefficient of quotient. What is the degree of the quotient? The degree of a function is 4. So the degree of quotient is 3. So this is the coefficient of x cube terms. This is the coefficient of a square term. This is the coefficient of x term. This is a constant. So our next factor is negative 4x cube positive x square minus 4x plus 1. So we have two factors, but this is not factor completely. Okay, we still need to factorize this. Okay, now in order to factorize this, we repeat the same process. Now this is your new function. Sorry, so this is your new function. Okay, now we find the rational 0. We find one real 0 for this function. Use the synthetic division and factorize. Okay, so let's find the rational 0 for this function. So we are focused on this one. Okay, so rational 0 is p over cube. So p is the coefficient of constant, positive 1 and negative 1. Q is the coefficient of leading term. That is positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. Okay, so our p over q would be, but it's easy to find the real 0 without finding the rational 0, right? Like, how could we factor? The x square. Oh, okay, that's the easiest way. So, okay, let's do that. Let's not do this one. But if you can't factorize, you can always go with this process. Okay, so we have the 4 terms. So let's make a pair of first 2 terms and last 2 terms. Okay, let's say this, if this helps us here. So we have x plus 3. So in the first 2 terms, we have x square common, right? Or we can just factor out a negative x square. So if we factor out a negative x square, we have a positive 4x, negative 1, right? So in the last 2 terms, let's factor out a negative 1. If we factor out a negative 1, we have 4x negative 1. Okay, this is helping us here. That's good. Now we have a common factor, 4x minus 1, 4x minus 1. So let's factor out this. So we have x plus 3. So we have 4x minus 1 common factor. And we have minus x square minus 1. Okay, so this is our factor for this function. Now we set each factor equals to 0. So we have x plus 3 equals to 0. 4x minus 1 equals to 0. Minus x square minus 1 equals to 0. Okay, once you factor completely, you can still factor this expression. Okay, but we know how to solve quadratic equation, so we are not factoring. Now we set each factor equals to 0. So you subtract 3 here. So x equals to negative 3. This is one real 0. You add 1 on both sides. We get 4x equals to 1. You divide 4 by both sides. X equals to 1/4. So this is the other real 0. Now we add 1 here. So we have negative x square equals to positive 1. So we need to get rid of this negative. So we divide both sides by negative 1. So our x square equals to negative 1. So x equals to plus or minus square root of negative 1. And what is the square root of negative 1? What kind of number do we get here? Imaginary number, and that is I, right? So our I square is negative 1. That means I is square root of negative 1. So we have a 2 real zeros. So we have this negative 3 and 1/2 as a real 0. And we have positive I and negative I. These are also a 0, and we call this a complex 0. Okay, because this is not a real number, this is a complex number. So our real zeros are, so you are asked to find the real 0. So real zeros are negative 3 and 1/4, And let me add here complex 0. So complex 0 is the complex number, so positive I and negative I. And all together, how many 0 we have? 4 0. And 4 is the degree of the function, right? So we always get the number of 0 equals to degree or less. And this is your homework 29. So I did for you. So you have 23. That's pretty easy. So try the remaining. And if you have any question, we'll discuss tomorrow.